So today I went to the supermarket from my home, and this is the road through which I went to the supermarket. This is, if I follow this road, then this road may be of, let's say, 100 meter. It's quite close here. 100 meter, then the distance I traveled is 100 meter. Now I want you to think for a moment, what would be the shortest distance from my home to the supermarket? You can pause the video, I wait. I hope you have already thought of the right answer, and that is from this point to this point. This is called the displacement. Shortest distance. So the road I went through was distance, but air distance, if I started my helicopter here and landed in the supermarket and went through this path, then it would have been a displacement, and it is always the shortest distance. So can you tell me now what is the direction of this distance? As you may have noticed, there is no direction of this distance. It's just a path with certain length. Now, can you tell me if this is north and this is west? Can you tell me the direction of the displacement to the supermarket? As you may have noticed, you may notice many things there. From here to here, the displacement has the direction. It is northwest direction. Northwest direction. So displacement is any quantity that has direction is vector quantity. So displacement is a vector quantity, and without a direction and only magnitude, this is a scalar quantity. Distance is a scalar quantity. Now let us think about another aspect of my journey. Let's suppose I covered the 100 meter distance in 50 seconds. 50 seconds I covered 100 meter distance. So my speed will be, the rate of change of distance will be 2 meter per second. Now what would be the result if I put in displacement? Now, as I said, displacement is always smaller than order distance. Let's suppose displacement was 50 meter. So it would have taken me half the time. Second. So by time is vector which is velocity. Vector velocity, yeah. So it took my speed remained the same, but I was traveling in this distance, the shortest distance, this direction. So even if my speed remained the same magnitude, the time I took was smaller because the distance was smaller. Of course, because velocity has got displacement and it is in certain direction, in this case in northwest direction, it is also vector quantity, velocity, and as speed is of distance, it is a scalar quantity. It is a vector quantity, it is a scalar quantity. Now let's talk about acceleration. It is the rate of change of velocity. As the term velocity comes in, acceleration is also a vector quantity. In my journey to home and supermarket, if my velocity kept on increasing, for example, let's say up to here, my velocity was 1 meter per second. Now here my velocity was 2 meter per second, and like that. Then from here to here my velocity increases by 1 meter per second, and each second. So its unit is meter per second square, and you can calculate it with change in velocity by changing time. Now let's see how to represent this in a graphical way. With a graph we can represent these ideas quite easily. First graph I want to show you guys is displacement time graph. Time graph is as the name says, we have time in here and displacement, or you could say anything meter in here. Displacement in meter, time here. So let's say this is 1 second, in second, 2 second, 3 second. This is 1 meter. No, let's do it. One, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 meter. This is not in uniform space, as you can see, it's just the concept man. So if in 1 second I travel 1 meter, in 2 seconds I travel 4 meter, in 3 seconds I travel 9 meter. If you join this, it would make a uniform curve. Now analyze this curve. To create the tangent, this draw tangent at 2. Now this tangent has a gradient. This gradient is y minus y2 by x minus x2. Yes, the x is y. This is 0, 0. This gradient happens to be 2, and the unit in y axis is meter, and the unit in x axis is second per second, 2 meter per second. So this gradient happens to be the velocity at that time. At 2 seconds, my velocity was 2 meters per second. This can be applied anywhere, even here. My x-axis, y-axis is in 9, so 9 minus 0. This is in 3 minus 0, 3 meter per second. Now, as you may have noticed, the graph shown here resembles the graph of y equals to x square. Now, that will come in handy later. Now I'll show you how the distance matter. For that distance we have to use how the area matter inside this graph enclosed with the x-axis and the graph. And for the area we'll have to use integration and differentiation in this example. Let's suppose, as you may have already learned in pure mathematics 1 or anywhere else, if we integrate this, if we differentiate this, then the differentiation gives us 2x. This 2x has its own pattern of graph. 2 is the slope here and x is the x-axis, as I have differentiated dt. I have differentiated with respect to the time, df, and 2 is the 1, 2. So in 1, 2, 4, 6. 1, there is 2 because 1 into 2. In 2, y-axis is 4. In 3, y-axis is 6, and goes on like this. So the y-axis. Now I want you to imagine what is the y-axis here. I'll give you the time to think. Pause the video and think. Okay. So, as we know, differentiation gives us the slope of this graph at the x-axis point. In this case, the time. In 1 second, the slope of the graph is the tangent drawn to the point would show the gradient of 2. At 2 it would show 4, at 3 it would show 6, and as we have already drawn, the gradient is velocity, so this is also velocity, meter per second. We have found a new graph with velocity in it. From the graph of displacement time, we have found the graph of velocity time in the same situation. Now, what would you think the area of this graph enclosed within x-axis represents? In this case it's just a triangle, so area is of this triangle is half, base is 3, into the height is 6 equals to 9, and the unit is meter per second times second equals to 9 meter. Now we have connected this in such a way that we got the distance till, sorry, this is of 3 seconds, and if we compare with this graph in 3 seconds, the distance was 9 meter, correct? So we got the distance 9 meter by the area enclosed inside the graph. Now what is the representation of the gradient of this graph? What would that represent? So gradient is in y axis there is meter per second, in x axis there is second, so it would be meter per second square. Now what does this mean? This means we have got acceleration, as I told you in the previous page. Acceleration, so velocity time graph gradient gives us acceleration. See here acceleration. Velocity time graph gradient gives us acceleration. What is the expression here? Just take 1 y minus, I have used this formula a lot, it is important. y2 minus y1 by x2 minus x1. So here y is 3. Suppose this is 0, y1 is 0. Here y is 3 minus 0 by 6. Suppose 6 minus 0 by 3 minus 0 equals to 2 meter per second square. So from this displacement time graph we have found out the new graph of velocity time graph. We have derived from that displacement time graph. We have found the acceleration, which couldn't be found out directly from here, from the gradient of velocity time graph, and from this area covered by the velocity time graph we have found the distance. Now doing just the opposite, if velocity time graph is given, we can find out displacement time graph. Just the thing is, we replace differentiation. If we integrate it, integration of 2x gives us y equals to x square, and we would get displacement time graph from velocity time graph. So integration and differentiation is important in this matter. Lastly, we need to talk a little about formulas of kinematics of motion in a straight line. Appropriate formulas will be, I like you to derive it yourself. I just saw the hint. Suppose I was moving to the supermarket. Take the same example. I covered distance of s, displacement of s, sorry, it's not distance. I was accelerating with a, my initial velocity is u, my final velocity was v, time taken was t. So how can we relate this all? Well, I like you to try it. I just give you a hint. Velocity is change in distance by change in time. Acceleration is change in velocity by change in time. So So now read this all and find the formulas. There are many formulas to be found, but I will not show you. You should do it yourself. And thanks for watching.